Lesson 19.2, Task 1, Quadratic Functions in Standard Form. All right, convert from vertex form to standard form. You can convert a quadratic function written in vertex form, f of x equals a times x minus h squared plus k, to standard form, f of x equals a x squared plus bx plus c, by expanding the x minus h squared. All right, so we are going to look at a little bit from before the 9 weeks ended. And so first we did look at multiplying polynomials together. So you should remember, if you have a binomial squared, this is a perfect square. So we've got x minus h squared. So if you remember, I'm going to write over here, we had something like a minus b squared, and that is equal to a squared minus 2ab plus b squared. We also, if this is a plus, that means this would be a plus. But we did work with polynomials and factoring before, so just kind of a quick review. If you want to expand this, you can use this formula. This is a big ACT question, so this is something that as you practice, you get more familiar with it, it will become easier and something you will see on and on through high school math. All right, so square the first term. This says square the first term, okay? So I'm going to have x squared. Then I'm going to have minus 2ab. So minus 2ab means minus 2 times both my terms. So minus 2xh in this case. And then I'm going to square my last term. So square the last term plus h squared. And again, this is always positive because when you square something, it's going to be positive. So this expanded is this right here. All right, so it says vertex form. We're just starting here. We've got a times x minus h squared plus k. And then if you expand this, you get this right here. And that's what I did right here, okay? All right, so it says distribute a. Because we had a times this binomial squared, we still have to multiply this binomial by a. So remember, multiplying polynomials, when this is in parentheses, you have to multiply a by each term. So you're going to multiply it by the first, second, and third term here. And that's where they get the line right underneath. So you're going to see that this ax squared comes from right here. And then a times negative 2ahx, that comes by multiplying the middle term. And then a times h squared comes from multiplying it by the last term here. So this is just multiplied out from this expression here. All right, and then you still have your k, so don't forget that. Make sure you bring that down as well. Write as the sum of an x squared and x in a constant term. So the x squared, remember, is your quadratic term. This is your linear term. And your constant is your number, or just your constant term is how we know it. So this is my x squared term. This is my linear term because it's got just the x. Remember, the a and the h and the k, these are going to be numbers in a real example. And only the x is what we're looking at as far as to know if it's a quadratic, linear, and this one doesn't have an x, so that makes that your constant term. Okay? All right, so it says recall that standard form is ax squared plus bx plus c. So that's why we've got the ax squared plus this equals our bx plus this part equals our c. All right, so what we can see is that in this expression here, b is here, b is our middle term, is going to equal negative 2ah. And c will equal the constant term, which is this last expression, is a h squared plus k. All right, so we're going to be using this information to answer the questions below. All right, so use the graph of the function written in standard form to answer parts A through F. All right, so we have f of x equals ax squared plus bx plus c. Remember, this is standard form where a is greater than 0. That means it turns up when a is greater than 0. If a were negative, this would be upside down. but in this case, a is greater than 0, so it's positive. So we want to evaluate and find out what these are. So it says the graph of f of x equals a times x minus h squared plus k, written in vertex form, has an axis of symmetry as x equals h. This function can also be written in standard form, f of x equals ax squared plus bx plus c, with b equals negative 2ah, which equation also represents the axis of symmetry. Okay, so if we look above here, okay, we already said this comes from this equation here, b equals negative 2ah. And if you remember in the previous lesson, our vertex is hk. So that was our x and y. That's what made up our vertex in vertex form. So we know that the hk. So what we're doing is trying to compare vertex form and standard form. All right, so if we know that b equals negative 2ah, how can we find h? So b equals negative 2ah. Let's divide by negative 2a. And you're not going to have to do this each time. They just want you to see how these two equations relate to each other. And if you want to put the negative on top, that gives you negative b over 2a. So that's our h. That's going to be the x in our vertex. Okay? So we can say that this right here is the answer for this question. So with b equals this, which equation also represents the axis of symmetry. Okay, so this was from standard form, and we are looking at standard form. If we want to find the vertex, we're going to start with x equals negative b over 2a. All right, complete the explanation showing how to find a quadratic function's extreme value. That's your maximum or minimum value. Remember, this comes from your vertex in terms of the parameters a, b, and c. Okay, so right here, we found the x. Okay, now we need to find the y value. All right, so we're going to do that using the formulas they gave us above. The extreme value of the function in vertex form, f of x equals a times x minus h squared plus k is, okay, so we know that the k value is your max or min. Remember up here we were looking for the h. That was our axis of symmetry, and the k value is your maximum or minimum value. All right, so the same function can be written in standard form as f of x equals ax squared plus bx plus c, with c equals a h squared plus k. And again, remember that came from right here. We said that c equals this when we simplified this expression. So this is just the general form, but it's going to work for all equations. All right, so if you look at this, we can say c equals a h squared plus k, and we want to solve for k. Right here we're looking for k. So if we do that, we're going to subtract ah squared from the other side. So c minus ah squared equals k. Remember, if you subtract this expression from both sides, all we're doing is moving it to the other side. Because we have an equation, we have to have an equivalent statement. All right, so let's see. Combining these two facts implies that the extreme value is c minus ah squared. But we also know that b equals negative 2ah. All right, so remember we looked at that in the one right above it. So if b equals negative 2ah, then we also can substitute in for h. Right here's h, okay? So let's see what they want us to do. So if we're going to substitute that in for h, we know that before we subtracted, or we divided by negative 2a, and we know that h equals negative sorry about that, that's negative. I'm moving the negative to the top, but it's just negative b over 2a. All right, so if we substitute this right here for h, we're going to have c minus a times negative b over 2a squared. All right, so again, all we're doing is substituting for h, so it's going to be the same equation, c minus a for all of these, and then substitute in the negative b over 2a squared, and that's going to be that fact. Now they want us to simplify it. All right, if we simplify it, we have to square this first, so we're going to have c minus a. Negative b squared is just b squared, the negative drops. 2 squared is 4, and a squared is a squared. Now, this is like negative a, that's like over 1, so the a can cancel with one of these a's, not both of them. So we're going to have c minus, and then just b squared over 4a. And again, that's just using order of operations and simplifying that expression. All right, so we're going to have c minus b squared over 4a. All right, so this is a little complicated getting started. You're not going to have to do this every time. They just want you to see how the two equations, standard form and vertex form, are connected. All right, let's see what else they're asking here. Using the expression for h and k in part a and b, which ordered pair represents the location of the vertex of the quadratic function? All right, so you can see right here, the x is negative b over 2a, and the y value, f of x is your y value, it's c minus b squared over 4a. So these are the two expressions that make up our vertex. So negative b over 2a, c minus b squared over 4a is the correct vertex. The y-intercept of the graph is the y-coordinate of the point at which the x equals 0. Complete the statements. The standard form of a quadratic function is, all right, so standard form, remember, is ax squared plus bx plus c. The y-intercept of a quadratic function is your constant term, c. The x-intercept of the graph of a function are the x-coordinates of the points when f of x equals 0. Complete the statement about the graph of a quadratic function. The x-intercepts are solutions of the equation. All right, so again, you're going to plug in 0 for y. What they did, here they're plugging in 0 for x, and here they're plugging in 0 for y. So it has to be the second answer. The x-intercepts are given by the quadratic formula that we learned before break. All right, so if you use the quadratic formula to solve, you can do that. All right, so I want you to take just a moment and use the quadratic formula and see if you can find each one of these answers here. Once you finish, I want you to resume and see if you got the same answers that I did. All right, so hopefully you took the information from the video above and went through the process. So the axis of symmetry, remember, x equals negative b over 2a. We are given this equation here, so we know that a, b, and c are these numbers here. So when you solve, you get x equals 3. That's your axis of symmetry. And then taking the equation we learned above, c minus b squared over 4a, this gives us 2. That's our maximum or minimum. Remember, you can always do it a different way. You can always plug an x into the original equation to find y. So I showed you that these give you the same answer. So I got a 2 when I use this formula. If you forget this formula, then you can just plug it into your original equation and get the same answer. So that gives you a maximum, or a minimum in this case, of 2, because a is 1, so we know it turns down. So that means the vertex is 3, 2. That comes from those 2 points there. The y-intercept is your constant term, so 11. When we use the quadratic formula, it gives us a negative number, so there is no